Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So I am going to show you the three ways of solving the problem using variation of parameters method in three different parts. So let's begin with part 1. Problem: solve y double dash plus y dash equals to 1 by 1 plus e power x or d square plus d of y equal to 1 by 1 plus e power x using the variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash plus y dash equal to 1 by 1 plus e power x. We can write y double dash. See, y double dash or y2 is nothing but d square y by dx square, right? You can have the same equation as y2 plus y1 equal to 1 by 1 plus e power x. And here y dash or y1 is nothing but dy by dx. Right? Now we can write y double dash as d square y by dx square plus y dash dy by dx equal to 1 by 1 plus e power x. Now we'll write d square y by dx square as capital D square y plus capital dy equal to 1 by 1 plus e power x. Now take y common from the first two terms of LHS, or the two terms of LHS will get d square plus d into y equal to 1 by 1 plus e power x, which is an equation in operator form, right? The equation in operator form. So consider the first equation as equation 1 and the equation in operator form as equation 2. Right, where f of d, or this is of f of d into y equal to some function of x form, we can say, where f of d is d square plus d. Now let's write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square plus d into y equal to 0. Consider it as equation number 3. Now we'll find the solution of homogeneous equation using the auxiliary equation, and later using the solution of homogeneous equation we'll find the general solution of equation 1 and 2. Here equation 1 and 2 are same, okay? Equation 2 is operator form of, the operator form of equation 1 is our equation 2, right? Now coming to the auxiliary equation, the auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus d, right? Let's replace the differential operator with m, so that we'll get f of m equal to m square plus m. Now the auxiliary equation becomes m square plus m equal to 0. Now take m common from the two terms, we'll get m times m plus 1 equal to 0. Now equate each factor to 0. We'll get m equal to 0 and m plus 1 equals to 0. M equal to 0 is one root, and from m plus 1 equals to 0 we'll get another root, m equal to minus 1. Then m equal to 0, minus 1 are the roots of the auxiliary equation. Therefore the roots are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then the solution to homogeneous equation looks like one constant, say c3 into e power 1 root into x, plus another constant into e power another root into x. Here I am taking c3 and c4 instead of c1 and c2 because I want c1 and c2 to appear in the last general solution, right? Now coming to the solution to homogeneous equation. y equal to c3 e power 1 root, say 0 into x plus c4 into e power another root minus 1 into x. This gives us y equal to c3 e power 0 plus c4 e power minus x, right? Since e power 0 is 1, then we'll get y equal to c3 into 1 plus c4 e power minus x, which gives us y equal to c3 plus c4 e power minus x, which is the solution to our equation 3, right? Fine, now we got the solution to equation 3. Using this solution, we'll write the general solution of 1 and 2 by replacing the parameters with functions of x. Let y equal to, replace the parameters c3 and c4 or constants with functions of x, a and b. Then we'll get y equal to a plus b e power minus x. Be the general solution. Of 1 and 2, because 1 and 2 are same equations, right? Where a and b are functions of x. Okay, so we are saying that y equal to a plus b e power minus x is a general solution. So we can say that it is a solution of 1, so that it satisfies equation 1, right? So let's find y dash and y double dash and substitute in equation 1. We have y equal to a plus b e power minus x, right? Let's find y dash. Y dash equals to a dash plus b e power minus x whole dash. This equals to a dash plus, here we are having two functions, we need to find derivative of two functions, right? Product of two functions. So we are going to apply uv whole dash formula, which is u dash v plus v dash u. This gives us b dash e power minus x plus b into e power minus x whole dash, which gives us a dash plus b dash e power minus x plus b into derivative of e power minus x with respect to x is minus e power minus x, which gives us a dash plus b dash e power minus x plus into minus minus b e power minus x, which gives us a dash plus b dash e power minus x minus b e power minus x. Now let a dash plus b dash e power minus x equals to 0. Let a dash plus b dash e power minus x equals to 0. Consider it as equation number 4. Then y dash becomes 0 minus b e power minus x, which is minus b e power minus x. We got y dash minus b e power minus x. Let's now find y double dash. We have y dash equals to minus b e power minus x, right? Let's find y double dash. Y double dash equals to minus of b e power minus x whole dash. This gives us minus of b dash e power minus x. Here also we are going to apply uv whole dash formula. Plus b into e power minus x whole dash, which gives us minus of b dash e power minus x plus b times derivative of e power minus x with respect to x is minus e power minus x, which gives us minus of b dash e power minus x plus into minus minus b e power minus x, which gives us minus b dash e power minus x minus into minus plus b e power minus x. Okay. Therefore, y double dash equals to minus b dash e power minus x plus b e power minus x. We have equation 1 y double dash plus y dash equals to 1 by 1 plus e power x, right? Now substitute y dash and y double dash in 1 will give us y double dash minus b dash e power minus x plus b e power minus x plus y dash minus b e power minus x equal to 1 by 1 plus e power x. This gives us minus b dash e power minus x plus b e power minus x plus into minus minus b e power minus x equal to 1 by 1 plus e power x. So here plus b e power minus x minus b e power minus x gets cancelled, and from this we'll get minus b dash e power minus x equal to 1 by 1 plus e power x. This gives us b dash minus b dash. We can write e power minus x as reciprocal of e power x equal to 1 by 1 plus e power x. Now take this e power x and this minus to RHS, then we'll get b dash equal to minus e power x by 1 plus e power x. Therefore b dash equal to minus e power x by 1 plus e power x. Right? We have equation 4. A dash plus b dash e power minus x equals to 0, right? We can write this as a dash equals to minus b dash e power minus x, right? And substitute b dash. We have b dash equals to minus e power x by 1 plus e power x into e power minus x, or you can write, see here you're having e power x and into e power minus x, or we can write it as e power x minus into minus plus e power x into e power minus x by 1 by 1, e power x into e power minus x by 1 plus e power x. If you consider e power x into e power minus x, we can write it as e power x minus x, which gives us e power 0. Since e power 0 is 1, so we can replace this term with 1, or write e power minus x as reciprocal of e power x. Now cancel e power x, then we'll get 1 by 1 plus e power x. Okay. So finally, a dash equals to 1 by 1 plus e power x. Let's find a and b using a dash, b dash. First, we'll begin with a dash. We have a dash equals to 1 by 1 plus e power x, right? Here a dash is nothing but derivative of a with respect to x equal to 1 by 1 plus e power x. Now let's separate the variables by taking differential dx to RHS. We'll get dA equal to 1 by 1 plus e power x into dx. Here the variables are separable, so we can perform integration. Integral dA equal to integral 1 by 1 plus e power x into dx, right? So here we have to find integral 1 by 1 plus e power x, so we'll just write e power x as reciprocal of e power minus x. Just consider 1 by 1 plus e power x. I'm just taking the integrand, and I'll write e power x as 1 by e power minus x, which gives us e power minus x plus 1 by e power minus x, right? Which is equals to e power minus x by e power minus x plus 1, right? Now we can replace the integrand 1 by 1 plus e power x with e power minus x by e power minus x plus 1. Okay, now let e power minus x plus 1 equals to some f of x. Let f of x equals to e power minus x plus 1. Then find f dash of x. F dash of x equals to derivative of e power minus x with respect to x is minus e power minus x plus derivative of a constant with respect to x is 0, which gives us minus e power minus x. So here we can apply integral f dash of x by f of x into dx, which is equals to log mod f of x, right? So in order to apply this formula, we need an f of dash, which is minus e power x in the numerator. So we need a minus here, and we have f of x in the denominator, e power minus x plus 1, right? So let's multiply, or just take minus into minus. 1 minus outside the integral and 1 minus inside the integral for our convenience. Okay, then this gives us integral dA a equal to minus integral f dash of x by f of x is log mod f of x plus some integral constant, say c1. This equals to minus log of e power minus x plus 1 plus c1, which is the required a. Or, so instead of taking 1 plus e power x as f of x, we can take 1 plus e power x as, instead of taking e power minus x plus 1 as f of x, we can take it as some t. Let e power minus x plus 1 equals to some t. Okay, now differentiate on both sides with respect to x. Which gives us derivative of e power minus x with respect to x is minus e power minus x plus derivative of 1 with respect to x is 0 equals to dt by dx. From this we'll get minus e power minus x equals to dt by dx, or minus e power minus x dx equals to dt, or e power minus x dx equals to minus dt. Okay, now just replace e power x into dx with minus dt and e power minus x plus 1 with t, which gives us integral dA is a equal to integral, replace or just write as it is. Okay, I'm going to write the integrand as e power minus x dx by e power minus x plus 1 for my convenience. Okay, this gives us, just replace e power minus x dx with minus dt by replace e power minus x plus 1 with t, right? Or we can write this as integral dA equal to minus integral 1 by t dt, right? From this we'll get a equal to minus integral 1 by t dt is log mod t plus some integral constant, say c1. From this we'll get a equal to minus log of t plus c1. Now just replace t with e power minus x plus 1, since t equal to e power minus x plus 1, then this gives us a equal to minus of e power minus x plus 1 plus c1. See, you'll get the same thing. Okay, here you'll get minus log. Okay, you'll get the same thing. Therefore, a equal to minus log of e power minus x plus 1 plus c1. Now we got a. Let's now find b using b dash. Using b dash we'll find b. We have b dash equals to minus e power x by 1 plus e power x Here b dash is nothing but derivative of b with respect to x equal to minus e power x by 1 plus e power x. Now separate the variables by taking differential dx to RHS, then we'll get db equal to minus e power x by 1 plus e power x into dx. Here the variables are separable. So apply integration. We get integral db equal to integral or minus integral e power x by 1 plus e power x into dx. Let 1 plus e power x be some q. Okay. Now differentiate on both sides with respect to x. We'll get derivative of 1 with respect to x is 0 plus derivative of e power x with respect to x is e power x equal to dq by dx. From this we'll get e power x equal to dq by dx, or e power x into dx equals to dq, right? We can replace e power x into dx with dq and 1 by e power x with q. This gives us integral dv equal to minus integral e power x dx by 1 plus e power x, which gives us integral dv equal to minus integral e power x dx can be replaced with dq by 1 plus e power x can be replaced with q, right? That gives us integral dv be equal to minus integral 1 by q dq is log mod q plus some integral constant, say c2. We'll get b equal to minus log q plus c2. Now replace q with 1 plus e power x. Since q equal to 1 plus e power x, then b equal to minus log of 1 plus e power x plus c2. Therefore, b equal to minus log of 1 plus e power x plus c2. So we got a and b. Let's now write the general solution using y equal to a plus b e power minus x. Therefore, the general solution is given by y equal to a plus b e power minus x. Then y equal to a minus log of e power minus x plus 1 plus c1 plus b minus log of 1 plus e power x plus c2 into e power minus x, which gives us minus log of e power minus x plus 1 plus c1 plus into minus minus e power minus x into log of 1 plus e power x plus c2 e power minus x, or we can write this as c1 plus c2 e power minus x minus log of e power minus x plus 1 minus e power minus x into log of 1 plus e power x, or we can take e power minus x common from the last two terms. So see, in the third term we don't have any e power minus x, so let's multiply and divide e power minus x to this term. Then we'll get c1 plus c2 e power minus x minus e power minus x by e power minus x into log of e power minus x plus 1 minus e power minus x log of 1 plus e power x. This gives us y equal to c1 plus c2 e power minus x minus e power minus x of 1 by e power minus x into log of e power minus x plus 1. We have taken minus e power minus x common from these two terms, right? So we'll get plus log of 1 plus e power x, right? Which gives us c1 plus c2 e power minus x minus e power minus x of reciprocal of e power minus x is e power x. We'll get e power x log of e power minus x plus 1 plus log of 1 plus e power x. Okay, we can just stop it here. Okay, or if you want e power x, you can just multiply and divide e power minus x. If you wish to take minus e power minus x common from these two terms, we'll just multiply and divide e power minus x to the third term, okay? Fine, therefore, y equal to c1 plus c2 e power minus x minus e power minus x of e power x log of e power minus x plus 1 plus log of 1 plus e power x is the required solution to our problem. So we have seen a problem from variation of parameters method in this video. I hope you will understand. We'll see you in the next video. Until then, bye bye.